Hello there once again. This is Professor Rodan with Topics in Mathematics. This is section 8.4. And in this video, this is the last video for chapter 8, Geometry. And we're going to only do worksheets number 9 and 12 in this video. And that'll be the ends for your video check and your work in class. So let us get started. So first of all, we're going to talk about volume. So volume of a rectangular solid. Okay, so it's a little tricky to draw these things, so I'm just going to draw a square and then draw another one right in the middle, starting in the middle, and now I'm just going to connect the corners, okay, which gives the optical illusion that this is three-dimensional when it's actually not. So we have length times width and height. And so volume equals length times width times height, okay? And this is a rectangular solid. Now, if all sides are congruent, then this is a cube. And if we know that all these different lengths, like length times width times height, we know they're all the same, so we can actually just look at it as side times side times side, which is the same as side to the third power. Okay, s squared, or s cubed, sorry. So technically there's a shortcut for the cube, and it is this formula, but it's not really necessary. You know you're going to do this formula here for regardless if it's rectangular or if it's all the same size, making it a cube. So let's go ahead and do volume of a cylinder. So a cylinder basically is like a can, soup can or whatever, vegetable can, or a tube, things like that. And so I like to highlight what we actually multiply. So this here. Now the volume of a cylinder, we need to calculate the area of the circle, which is the same on both ends and all the way up through the cylinder. We're going to multiply that area times the height. Okay? And this circle, of course, has a radius. Okay? So our formula then is going to be the area of the circle on the bottom, which is pi r squared, times the height of the cylinder. Okay. Next, let's do pyramid. Now, this is, I'm not going to just do one generic pyramid. I'm going to show you various pyramids, okay? The pyramid concept is basically if I do a third of this, if I do a third of a cube here, okay, I'm going to get the volume of a pyramid. If I do a third of the cylinder, I'm going to get the volume of a cone. So the whole concept to remember is dividing by 3, okay? But we'll see what type of base that we have So you have different bases. So let's say you have a triangular base. Okay. And so the area of the base, as you can see, is a triangle. Okay. And we would need the formula for the area of that base, which is a triangle. Okay. And of course, this thing has a height all the way to that. Okay, next we have, let's say if it's a rectangular base, okay, if it's a rectangular base, then we need to know the area of this base here. And then pretty much any polygon. I'm just going to do a hexagon just as an example, just to show you that the base could be anything. It could be a circle. Okay. Okay. So it doesn't matter what the polygon is at the bottom. Okay, the volume is going to be whatever the area of that base is. Okay, so I'm going to call that capital B times H, and then divide by 3. It's very simple. It's base times height divided by 3, but the base is an area. Okay. So it's an area of any base polygon. Okay, we'll see some examples in a minute, but basically, once you know the area of that base, you're going to multiply it by the height. Okay, which goes up to the tip of that thing. All right. So same thing with a cone. What if the base was a circle? Same concept. We got to find the area of this base and then multiply it by the height and then divide by 3. So since we know this is our general case here, but where B, in this case B, the area of the base is a circle, so that's pi r squared. So that means we're going to put pi r squared here for the B, multiply by the height, and then divide by 3. Okay? So that doesn't look too bad. And then we have the volume of a sphere. Oops. Okay, trying to make this circle three-dimensional. It does have a radius, as usual. So this one's a little weird, but it's 4/3 times pi r to the third. Okay? All right, let's get started with some applications here on the next page. Okay. So I'm going to do the odds here. So this is a rectangular prism, or solid. So it's length times width times height. So it's just going to be 6 times 4 times 7, which is 144 centimeters cubed. Okay, so there's 3. So it's centimeters times centimeters times centimeters is centimeters to the third power. Okay? And that's signifying that we are dealing with three-dimensional unit or volume in this case. Okay. Let's do number 3. So notice we have a, this is not a pyramid, but it almost looks like a rectangular solid. So if we finish it, this would be a rectangular solid, okay? But it's half of it. Okay, so this is half of a rectangular solid. Or we can call it maybe a triangular prism. But the point is, we're going to pretend that we have the whole solid, but we're just going to cut it in half. Okay? So 3 times 4 times 7 divided by 2. Put that in your calculator, and you're going to get 42 centimeters to the third power. (42 centimeters cubed). All right. Or cubic centimeters, doesn't matter. Okay, number 5, definitely have a cylinder here. So we're going to do the area of the base times the height. And the area of the base is a circle. So we have pi times radius squared times the height. And you put those numbers together without the pi, you're going to get 160 pi. Some books actually want you to stop there, but we're going to continue by using your calculator key for pi, and we're going to do 502.65 cubic centimeters. Okay, so we're just filling in these formulas here. Number 7 is a sphere, and we have 4/3 pi times radius to the third. To the third power. So we put that in our calculator. 6 to the third times 4 divided by 3, we're going to get 288 pi. That's the exact, and then the approximate after rounding is 904.78 millimeters cubed. Okay, so that's it for volume. We're not going to do surface area, and be ready to do the evens, or have your questions ready for the evens as well. All right, let's move on to the next page. Okay, so now we're going to mix 8.3 and 8.4 a little bit in what's called problem solving. So these are going to be word problems where we get to use geometry and basic math, arithmetic, basically to complete or to solve these problems. So let's start with, I'm going to do the evens this time. Oops. So let's start with number 2. Okay, so we have a lawn that needs to be fertilized, and so we need to buy, or Steve needs to buy fertilizer, okay? And he goes to the store to see that one bag will cover 5,000 feet. So we need to know how much lawn is there, and basically the lawn is going to be the total lot minus all the structures that are there. Okay, so the lawn is going to be the whole lot. It's a rectangular lot minus all the structures. Okay, so let's first calculate the lot. And the lot is one big rectangle here, length times width. So that's going to be 150 times 180. And that's going to be 27,000. Okay, so if the lot was empty with no structures, then we would do minus 0. And this is what we would work with. Oh, that's not. It's just, there's my lot. Okay, let's do my structures now. So we have, obviously we have a house, but we have to also add the pool and the driveway, which is not going to be grass, and the rose garden. Okay, so we have 3 rectangles and a circle. So the house is just going to be 40 times 60. The pool is going to be 20 times 30. The driveway is going to be 16 times 40. And then the garden has a radius of 12. Half of that diameter, so this is going to be pi times 12 squared. Okay, so we're going to get 2400 plus 600 plus 640. Okay, so we put all this together here, and including the pi and all that. The calculator takes care of all that business. Okay. And here's our structures. So now we're going to go ahead and do the difference between those two. Okay, so again, the lawn is going to be 27,000 minus the structures, which gives us 22,907.61 feet square. Okay, so this is how much needs to be fertilized. That's the lawn. So the next question is, well, how many bags are we going to need to cover that if each bag covers 5,000 feet? Okay, so we need to go ahead and so let's say, so bags for lawn would be how much we have to cover divided by one bag, which is 5,000. That's going to give us how many bags we need to cover 22,000, which is, in the calculator says 4.58, but you can't do half of a bag. You can't buy half of a bag, so you're going to have to actually buy 5 bags. Okay, you are going to waste a little bit of fertilizer. You're going to have some extras, and that's okay. So that's going to give you 5 bags, and then each bag costs $29.95. So now our final, our last result would be, okay, how much is this going to cost? That's the bottom line, basically. How much do I have to spend from my budget and all that good stuff? So it's going to be 5 bags times $29.95, and that gives us $149 and $149.75. Okay, so about $150 we're gonna need to do this. Okay, so this is a problem that we had, and of course most people won't do this. They would just guess, and most likely they would buy 3 and figure out, oh, I need 2 more, or they would buy 10 and say that's way too much. Now I have to go back to the store and return a lot of unused bags. So doing the math and will save you some time and some headaches. All right, let's take a look at the next even question. All right, so in this case we have Madeline, who's ordering pizzas for a Little League baseball team, wants to be cost effective. She called Pizza Hut, Papa John's to see which one has a better deal. And Pizza Hut sells a 16-inch diameter pizza for $15. Okay, so let's go ahead and put that down here. Pizza Hut sells 16-inch for second here. Okay. So 16-inch for $15. And we have Papa John's for $12. So theirs is 14 inches. So obviously Papa John's is cheaper, but you're getting less pizza. But we need to equalize the playing field. We need to level the playing field here so that we can see which one is actually cheaper per square inch. Okay. But they look really close. So let's see here. So the area is going to be pi times radius squared. We know that the radius is 8, which is half of that. And that's going to give us 201.06 square inches of pizza. And Papa John's is going to be that's 7. So 49 times pi is 153.94. Okay. So now let's compare the total inch squared or the area to the cost. Okay, so we want to know the price per square inch. Price per square inch means that the price should be on top of the ratio and the square inches on the bottom of the ratio. So price per square inch is going to be, so cost is going to be $15 divided by 201.06, which gives us 0.075. Okay, per inch squared. So it's about 7.5 cents. Okay. Let's see how much Papa John's is. $12 divided by 153. So this is going to give us, okay, so as you can see, guys, it's almost the same thing. We're talking about 1/10 of a cent. So 7.5 cents versus 7.8 cents. It's not much of a difference. Okay, so not a big deal. Just choose the one that tastes better, or that is closer, or that has some kind of deal for delivery, whatnot. Okay, but based on those two deals are basically the same in price. If you're hungry, buy the bigger one. Spend a little bit more out of pocket, but you're gonna get the same amount of pizza if you bought the Papa John's for $12. All right, let's go to the next even. Okay, so this one is number 6. Jim and Joe have built rectangular stage. Okay, there's our info right there of what we're looking at. The stage measures 30 by 52. Okay, thank you very much. They want to tile the floor of the deck and put a ledge to hang lights around the perimeter of the stage. Okay, so they want two things. They want to cover this with tile. So that's area. And they want to put a ledge. Okay? The ledge is going to be perimeter. So there's two lengths and there's two widths all the way around. Okay, so the tile, let's do the tile first. So we know that we have 30 times 52, and that's going to give us 1560 that we have to cover. And so the cost of this is going to be it's $1.50 times total square feet, and that's going to give us $2,340 for the project. Okay, so then now the ledge, which is I'm going to do in blue, and it's a wood ledge, costs $1.98, and then we're not calculating tax. So let's move this over here. Okay. All right, so the perimeter is going to equal 2 times 60 and 2 times 30, which is going to be 164 feet. And once we know how long we have to cover, we're going to go ahead and say, okay, the cost of doing that is going to be $1.98 times 164. And that's going to give us $324.72. Okay. All right, so we're solving problems. Whoops. And now we're going to look at number 8. Okay, number 8. Savannah is planting various colors of flowers in a circular shape on the front lawn of her new business. So the circle has a diameter of 10 feet. Let's go ahead and get this down. And the flowers cost $12 per square yard. Find the cost of the flowers. Okay, so we have a slight problem here because in the store it's per yard, not per feet. So we'll have to convert that a little bit later. And that's the only reason why we talk about that. So let's do, area. So we know that the radius is 5. So 25 times pi is going to be 78.54 feet squared. All right. Well, we can't multiply this by 12 because it's not $12 per yard. Okay. So what we do know is that 1 yard equals 3 feet. So in talking about square yards and square feet, you just have to square both of these, square both sides, and that's going to give us 1 yard squared equals 9 feet squared. Okay, so that's the conversion for square yards and square feet. All right, so first we got to see how many square yards there are here. We got to divide this by 9. Okay, so square yards is going to be 78.54 feet squared divided by 9. And that's going to give us 8.73 yards, square yards. Now we know how much we have to buy. So for every one of these yard squares, we have to pay $12. So now we go ahead and multiply $12 times 8.73. And that is $104.76. Okay. So we got the area, square yards, and the cost. All right, last one, number 10. So a box is 12 inches wide and 6 inches in length. If the height of the box is 4 inches, then how much paper would be needed to wrap the gift for Shelby's birthday? Okay, so a box looks something like this. Okay, and it's a 4, 12, and 6. And this is not volume, this is wrapping. So wrapping would be surface area. Of 6 sides. Okay, and we know that there, of those 6, two are the same. So two sets of two on opposite sides are going to be the same exact surface area. And so we can do let's see, twice the length times the width. We can do twice the length times the height, and we can do twice the width times the height. Okay, those are your 6 sides or faces. So length times width would be 12 times 6, sorry. Times 4 and 4 times 6. And that's going to give us, if you put this all in your calculator, which you can just type it in all at once if you have a more of a modern calculator, updated one. 288 inches squared. Okay, so that is it. We'll do some of these together, and that is it for chapter 8. See you in the next unit.